Okay, cool. So thank you for that introduction, Carrie. So yeah, I'm just going to talk about Audubon Canyon Ranch's Living with Lions project, kind of what our project goals are, what we do, and then dive a little bit into my graduate thesis and what some of my analyses will be with that. So that'll be a little more in depth, that last portion there. So my involvement in the project is a bit of a complicated affiliation. So I am a wildlife biologist with the Institute for Wildlife Studies, and they're based out of Arcata. And so I joined this project in 2021 just as a wildlife biologist. And then after a couple months, I kind of started transitioning my involvement to become a graduate student. So now I'm with the University of Nebraska Lincoln, and I'm also partnered with True Wild. And so overall, my thesis with the University of Nebraska, I'm just investigating mountain lion diet, space use, and energetics across gradients of human disturbance. And so just looking at the project overall, typically when you think about mountain lion research, usually you're thinking about some large contiguous tract of national forest land, with very few people and very few land parcels, just nothing but open space. Obviously, that's not the case here in the North Bay. So this area is definitely a mosaic of land use ranging from urban and suburban development to more natural and conserved areas. And then throughout its entirety, the parcels in this area are very small and mostly private lands. So that adds some complications just in the feasibility of research, just in accessing different areas. And it also makes things complicated for mountain lions as well. And as a whole, mountain lions are a keystone species. So the function of the ecosystem is dependent on their presence. They're indicator species as well. So their presence and or absence is indicative of ecosystem health and function. And so with most research regarding mountain lions and large carnivores as a whole, for that matter, occurring in these more natural, undisturbed systems, there's kind of a significant knowledge gap there. So with the research happening there, we know the ecological roles that these carnivores play in these undisturbed systems, but it's not exactly clear how all those elements kind of transition when you get along kind of the urban edge here. So we don't exactly know the role that they're filling, and that is a bit of what we seek to understand. So yeah, it's super important to try and identify these different knowledge gaps and fill them. So as a whole, very broadly, with this project, we seek to understand mountain lion habitat use. So where are they hanging out? What areas are they selecting? And potentially more importantly, what areas are they avoiding? And with all that, what is their diet? So what are they eating? Where are they eating it? And how does that diet change when there's more and more people and different species across the landscape? And then movement patterns. So identifying different habitat corridors, and just how they're moving about, when they're moving about. So if they can't get away from people, are they moving at different times of the day when people aren't present on the landscape? And then a huge part of the project as a whole is the outreach and education. So teaching the general public about mountain lions, what they can do, different aspects of safety. And then in general, we can take all of these components, the educational side, as well as more of the data side, to inform management. So just preventing development of certain corridors that are important to mountain lions, and then ultimately just preserving their existence in this landscape. And so to do all of these to do all of these analyses and satisfy our goals, we need a heck of a lot of spatial data. So the way that we do that is through collaring mountain lions. And it is no easy task, to say the least. So in a perfect scenario, one way that we go about it is placing a roadkill deer or something of the sorts out in the woods, taking an educated guess, thinking, okay, a mountain lion should walk by here. Most of the time, that's not the case. So you'll get things like bobcats. Every now and again, you'll get a golden eagle. And then on a very rare occasion, you'll get a mountain lion. So when a mountain lion starts feeding on a roadkill deer or any form of bait in the woods, they'll cache it. They're just like a big house cat. So they'll cover it up and during the day, they'll bed off, they'll leave, go about 100 to 200 meters away. And then they'll come back subsequent nights and feed until all of the food is gone, and then they'll be on their way. So we go in there during the day and take the carcass, and we're able to put it in the back of a cage trap, like you can see in the picture on the right. And those cage traps have a pressure plate in the back of them. So the lion theoretically will walk in, step on that pressure plate, and then the door up front that you can see there will fall. We go in with a veterinarian and then do what we do. But even then, I hope this video works well on your end. So you can see this mountain lion's approaching the cage trap, super weary because he can tell that, that deer is not how he left it earlier in the morning. And it looks like he's going to go in, but last minute, something's not right. So he's out of there. So yeah, just overall, it's really difficult just from even getting a mountain lion on the bait to ultimately capturing them. So one thing that Dr. Quentin Martins invented was a form of walkthrough trap to more passively catch these lions. So in those baited scenarios, that was the back of that trap is closed and there's one entrance, one exit, that one front door will fall, and that's that. With these walkthrough traps, both ends are open and there's no bait or scent involved. So the big thing with having bait in the equation is the mountain lions are inherently more weary. So like in that last video, that deer is not how he left it. So he's worried from that circumstance. And if it wasn't, so it's either not their kill, and if it's not their kill, then it's someone else's. So they're worried about the confrontation that another lion could be in the area and come up and say, hey, what are you doing eating my meal? So just in general, these walkthrough traps are a way to kind of remove the bait and any of the weariness associated. So we put these open on both end traps on different corridors and areas that lions will walk through. And when something walks through, there's a part on top that's sending ultrasonic pulses down and actually measuring the height of what's walking through the trap. So if something like a bobcat or a fox were to walk through, the trap wouldn't trigger because it knows that what's walking through is too small. It's not a mountain lion. And then when everything's right, when the height is right, mountain lion will approach this trap. The ultrasonic pulses will be sending down, and then the trap will trigger, and then the lion is in there. So then we'll mobilize immediately. These traps have all different sorts of transmitters on them, so we'll get all sorts of notification. We have a veterinarian with us on all captures. And then, so first things first, we immobilize the lion, take it out of the trap, do some overall body condition stuff, a bunch of measurements, take overall health parameters, all that while kind of making sure that vitals are all safe and sound. And then last but not least, we'll put that radio collar on, and then that individual would be reversed, and then they're on our radar. So we can track their movements across the landscape. So you can see this picture on the bottom is very similar to the collars that we use. So the way that we use the collars, we get a GPS location every 2 hours. And then on the fourth fix, so every 8 hours, the collar will send all of those locations via satellite. And then we're able to pull those down just on a website and see where the lions are at. And then using it this way, these collars last about 2 years. So once you're kind of getting past the 1.5 year mark, then we'll actively start looking to capture the individual again and put a new collar on. So as you can see from this map, once we have multiple lions collared for a longer period of time, you can kind of see how they're spread throughout the landscape. So this is all 12 individuals that we had collared in the calendar year of 2022. And this totaled to just over 35,000 individual GPS points. So overall, long-term, we can do a lot of analyses regarding spatial ecology with those collar locations. And so humans dominate much of the world's ecosystems, and thus it is imperative to understand the movement and selection of resources by mountain lions. And it's especially true and interesting with mountain lions along the urban edge because they are actively avoiding humans. So, how does this change? Once again, this kind of goes back to something that you wouldn't necessarily, a conclusion you wouldn't be able to gain from the studies in more conserved areas. And then additionally, mountain lions are such far ranging mammals. So they're using these huge areas. It's impossible for them to entirely remove themselves from humans, even though, they would love to do that. So there is an inevitable overlap that's important to identify and understand. So just kind of to bring that overlap to life, this is the home range of male mountain lion P5. And so one single territory, his territory alone contains over 17,000 private land parcels. So he's continuously going about all that fragmentation and just moving and kind of carving out a living in this really unique area for mountain lions to persist. And in addition to all that, each of those parcels is truly like an individual ecosystem. So, most of them are fenced, and you've got one individual who has native vegetation that's left pretty wild. The next person has the same kind of vegetation with artificial watering. And then two doors down, they've got entirely non-native vegetation. So there's a real altered availability and accessibility to their preferred prey, black-tailed deer, and how the deer are kind of present on the landscape. So that's another significant knowledge gap that really needs to be better understood to properly conserve lions in this area. And so taking a further look into that anthropogenic infrastructure and specifically the fencing. So there's a lot of research out of South Africa regarding wild dogs. They'll actually use different barriers and fences to chase different types of antelope and strategically corner the individuals against these fences to increase their hunting success. And this has never been documented in a solitary ambush predator like mountain lions. So, these wild dogs are more coursing cooperative predators. They're going to be running around in a pack and kind of corralling their prey. Whereas the mountain lions, they're hunting alone, and there is a very good possibility that they could be orienting themselves along these different boundaries to also increase their hunting success. So this next slide, and it'll start as soon as I change it over there, is a video right along a fence of a mountain lion actively chasing a deer. And I'm not sure you'll be able to hear it. It's tough to hear, but you can hear the ting of the fence as the deer runs into it. So, all it takes is that one stutter step. And that's a super big advantage for the lion, just in it being a successful hunt or not. So you can see those eyes in the background there. The deer knows nothing's going on. And then we did go into that area and found where the lion had killed that deer, and it was right up against the fence. So taking all this into mind, and this is kind of gearing more into my thesis side of things, I've kind of hypothesized with this that home range sizes of mountain lions will vary along these gradients of human disturbance. And this should ultimately result in larger home ranges in more developed areas. And specifically, I'm predicting that these home ranges will be larger in areas of greater development as they'll encompass more of the unavailable habitat that is kind of becoming more and more on the landscape. So just to take a look at this visually, in the broadest sense, a home range for any individual, mountain lion or not, represents the minimum area from which that individual can obtain the resources that it needs to survive and reproduce. So to make easy numbers, let's say that this mountain lion's home range is 100 square miles, and this is in a truly conserved area with no human disturbance. So that 100 square miles is what this individual needs to get what it requires to survive. So when you bring humans into the equation, and you've got things like low density housing and some outdoor recreation, and then additional things like livestock, hobby farms, A mountain lion's home range, we're hypothesizing, will balloon because it'll need to encompass, some of those vineyards and that low density housing to be able to get what it needs to survive. And so it'll continually balloon as there's more and more disturbance present on the landscape. And then it'll get to an extent where the development is just too immense. So it's just too big to fully encompass. So at this point, a mountain lion's home range would become constrained by the development, and it'll shrink drastically. And this is where you can run into huge problems. At this point, important habitat corridors are likely developed. There's probably very little gene flow and mating opportunities, and you can run into inbreeding issues and just individuals simply not being able to obtain the food and resources that they need to survive. So in a general sense, male mountain lions will occupy a home range of about 200 square miles. So they use a huge area and they're territorial. So a male will peruse that home range and he'll protect it and prevent other males from kind of infiltrating that area. And within his 200 square mile plot, there's likely to be 3 or 4 females that have their own 50 square mile or so plot. So understanding this sociality and the territoriality of how mountain lions socially function, you can kind of piece together their presence on the landscape. So given that everything's suitable habitat, it's just like a puzzle. So say there's about 5-ish mountain lions per 200 square miles. You can then kind of get some estimates of how many mountain lions are present on the landscape. And it only gets better when you add in things like genetics and other variables that can help kind of increase the accuracy of that answer. So bringing things super local, this is male mountain lion P13. And you can see in the figure on the right, that dark purple polygon is his entire home range. So all of his GPS locations are inside of that polygon. And then that more squiggly inner polygon is his core area. So that's where he spends more than 95% of his time. And so as a whole, his home range, that outer boundary, is 234 square kilometers. And he's moving throughout just shy of 7,000 private land parcels. And then that core area drops down to 168 square kilometers and just 2,800 private parcels. So you can see the number of parcels drops significantly relevant to the size of the home range. So he's in his home range selecting the areas with the least amount of disturbance and human presence on it. And then also on this figure, you can see those yellow dots are areas that I've gone in and investigated and found where he has killed deer. And actually, he has killed a deer on the Fairfield Osborn Preserve. So that's actually how I got introduced to this opportunity, was P13 spending some time on that preserve. So moving on to my second hypothesis regarding the spatial ecology, we're hypothesizing that large carnivores will exhibit altered resource selection patterns on the urban edge as human disturbance influences the availability and accessibility of resources. So specifically, we are predicting that mountain lions on the landscape along this urban edge, they're going to avoid human features. Plain and simple, they want to minimize that human encounter. And right alongside that, they're going to select those natural features on the landscape. So those bigger, more undisturbed parcels, different habitats that are best for them. And this will really be catered around the food rewards associated with those natural features. And then we are predicting that they will select fencing to aid in predation success. So this is like that video. Mountain lions are potentially orienting themselves to increase their hunting success. And then we predict that the avoidance of human disturbance is stronger in more developed areas. So as you move along that gradient of human disturbance, kind of that avoidance is going to become stronger and stronger because the risks associated are also getting stronger and stronger. And then lastly, we're predicting that all of the home range stuff may kind of fall through with subadult individuals. So we predict that subadult resource selection will not track the typical risks and rewards that we're expecting to see in the adult territorial individuals. So just taking a closer look into that final prediction where the subadults will kind of move around and act differently. So overall, home range analyses and any home range stuff in general only holds true for adult males that truly have a home range. So a mountain lion will, after birth, they'll spend time with their mom from anywhere from 12 to 18 months. And then from there, they'll kind of split off and try and go find their way in the world. And for females, oftentimes they don't have to go far from their mother. They'll kind of stay within that maternal area and just carve out a living there. Males, the mom will kick them out strictly for inbreeding reasons, and they'll go on a more longer journey, and then they'll try and find an area that's open and create a large home range that can be theirs. And this is really like a high stakes game of hide and seek for these juvenile males. So when they're moving throughout the landscape, if they encounter another territorial male trying to find their own ways in the world, there's a really good chance that they'll get killed by that bigger adult male. And then ultimately, if they survive, they'll set up shop and then they'll defend that territory and they'll become that adult male. So on this slide, that's a picture of P36. He was born on Taylor Mountain, just outside of Santa Rosa. Once he left his mom's side, he went north and spent 6 to 8 months between like Healdsburg and Calistoga, right on the county border there, with an occasional jaunt up into Lake County. And then right after Thanksgiving this past year, he must have ran into a bigger, badder male, and within 10 days, he was right beside the Golden Gate Bridge National Recreation Area. So he shot straight south, and to this day, he's still kind of bouncing around Marin County, looking to set up a more permanent home. And so this next slide has a video on it. It'll start right away. And it is an altercation between two lions. So this is kind of the fierce fights that can occur if a subadult were to run into an adult male. And just as a disclaimer, this is not P36. This is an unknown lion. So start this video here. Oh. It might not cooperate with us. Oh, there it goes. Yeah, so you can see it's a pretty intense fight there. That video was from the Monterrey area. And so a lot of times, go on here, sometimes that younger juvenile individual doesn't make it out so lucky, so they can be killed, and they will, come out as a meal for the adult lion most of the time. So this is not P36. This was just a different male that was found in the North Bay, but that can definitely be the outcome. So just to really highlight that is a dangerous journey for them. And so moving along into kind of a more analytical side of things, investigating the rest of those predictions, just in understanding if what habitat types mountain lions are selecting and what features of the landscape that they're purposely avoiding. So to do that, we conducted some resource selection functions, and these are within home range resource selection functions. So it's at the third order. So basically, we're assuming that anything available in a home range is available to that individual. And then we, for our circumstances, use locations are GPS telemetry spots, and the available locations are systematically sampled home ranges. So just millions of points throughout that entire home range to get really a good idea of availability of everything. And we did some nerdy statistical tests, and it's a binary 1-0 response. So did they use that particular location or not? And then through kind of this use versus availability framework, we can get a better idea of selection versus avoidance of different landscape features. So for this analysis, I input 189 deer feeding sites as the use locations. So specifically, we're looking at when mountain lions consume deer, what features of the landscape are they selecting and what features of the landscape are they avoiding? So I investigated all these locations just by hiking to them and taking note, okay, this lion did feed on a deer, and there were 11 mountain lions included in this analysis, 6 males, 5 females, and on average, there were 17 deer kills included for each individual. And so before I get into the true results of this, just taking a look at where these kills occurred by habitat type. So you can see the figure on the right, that is Napa and Sonoma County, and all of those black dots are the deer kills across the landscape. And then it doesn't really matter, you can't see it well, but just the main takeaway from that figure is just seeing that they do occur in different habitat types, so different forms of land cover. And so overall, by a lot, most of the kills occur in evergreen areas. And so this makes sense, you know, those cooler microclimates of the drainages and those lower elevation areas host evergreen forests, and oftentimes mountain lions will make a kill and drag that kill downhill and feed on it in those thicker areas until it's gone. And that's followed up by mixed forest, herbaceous areas, and shrubby areas. So now moving on to the output of that resource selection function, kind of in interpreting this graph, these are distance covariates. So like buildings, the forest types, and that kind of thing. Negative values show selection of that landscape feature, and positive values show avoidance. And then for the classification variables, so the classification variables are just slope, elevation, and productivity. You read it in the inverse. So negative values show avoidance and positive values show selection. So I know that's a lot to take in, but in these next couple slides, I'm going to just highlight a few of the specific landscape features, and we'll talk about it from there. So first and foremost, looking at buildings, it's a distance covariate, so you can see that there's a pretty strong avoidance for the buildings. And even though the mountain lions are strongly avoiding buildings when they consume black-tailed deer, they're still on average 377 meters away from the nearest building. So this just kind of shows that even though they want to get away from buildings, the development on the landscape in this area is significant to the point that they can't really get that far away. And so moving on, evergreen, also a distance-based covariate. So this is a really strong selection for evergreen forests, and it's the strongest of the forest types. So compared to mixed in deciduous forests. And then on average, all of the kills were 78 meters from the nearest evergreen forest. And then moving on to our first classification variable, which is productivity. So in this case, productivity is just a measure of biomass available on the landscape. So this is a really strong selection. And from a mountain lion's perspective, it's likely more of an indirect selection. So these productive areas, you can think of them as really green areas with tons of forage, are going to be directly selected by the deer. And because the deer are more abundant in these highly productive areas, the mountain lions are also selecting them, you know, when they're killing and consuming deer. So it makes total sense that is the way it is. And then, and then lastly, looking at the fencing. So this is the potential that mountain lions are using fenced areas to corner prey and increase their hunting success. Also a really strong selection. And on average, kills were 86 meters from the nearest fence. And so the key takeaways from this resource selection function and some of the spatial analyses overall is both anthropogenic and the natural landscape features influence where, when, and how mountain lions consume black-tailed deer. And then in general, the anthropogenic landscape features are pretty strong avoidance. Even the natural landscape features that were avoided, the magnitude of that avoidance is much stronger for kind of the human-based features on the landscape. And the exception of this is the fencing, where they're able to increase their hunting success. And then lastly, another important note is there is no available data in North Bay regarding black-tailed deer abundance and distribution. So it's not that this data couldn't be obtained, it's just that there hasn't been any studies on deer in this area. So kind of how they're distributed on the landscape isn't as known as we would like it to be, just to properly conserve mountain lions. And so moving on, next we'll take a pretty deep dive into mountain lion predator-prey dynamics in a human-dominated landscape. So understanding predator-prey interactions is fundamental to ecology and conservation. And these interactions absolutely shape ecosystems just by influencing things like habitat use, foraging patterns, and ultimately the evolutionary tracks of different species. So it's like the lynx and the snowshoe hare shown here. Their evolutionary tracks are pretty hand in hand in hunting and or avoiding each other. And so when you kind of add people into the equation, these interactions can become clouded and they become harder to predict. And without understanding, the basics of predator-prey interactions, you can't truly conserve and manage for these species. And there's a really high likelihood that a lot of these predator-prey interactions are system specific when it comes to the urban interface. So yeah, we've put a lot of time and effort into getting a better understanding of these interactions overall. And then just honing it into mountain lions. Once again, mountain lions are keystone species, so the function of the ecosystem is dependent on their presence, and they are obligate carnivores. So mountain lions in the urban edge aren't going to be like black bears or something where they're getting into your garbage, or like deer where they're chowing down in your gardens. They're strictly going to be eating deer, and they're strictly preferring their ungulate deer prey. And so on different urban systems throughout the Western US, there has been a documented decreased reliance on ungulate prey. So this is just because they, are switching to other things, other animals present on the landscape with the human presence. And this is really important to note because just energetically, mountain lions are large-bodied carnivores, so they should be selecting for that large natural prey, which is the deer. And then last but definitely not least, are the energetic inefficiencies that are present for mountain lions in human-dominated landscapes. So if you're a mountain lion and you're actively avoiding humans on the landscape, you'll be taking the long way around, you'll be selecting for steeper slopes and just drastically changing your movement to avoid humans on the landscape as compared to if there weren't humans present. So if there was no humans present, they're going to be taking that path of least resistance, but it's kind of, they still would like that path, but they would like more to avoid the people. So there are energetic repercussions. And with that, do they have to calorically compensate for that? So that's another aspect of all this that we're looking into. And then just diving into some of my hypotheses with my thesis, we hypothesized that mountain lions have higher kill rates in more disturbed areas to compensate for the energetic inefficiencies. Specifically, we predict that black-tailed deer kill rates will increase with the human disturbance. And we predict that the time spent at kills and the biomass consumed will not differ across gradients of human disturbance. So second, we hypothesized that a large carnivore diet is similar across gradients of human disturbance, as large prey is needed to sustain their larger body mass, as I mentioned. And specifically, we predict that black-tailed deer will be their primary prey across all of the North Bay. So whether this is in the most conserved or the most urban portions of this area, deer will be their number one. And additionally, we predict that dietary breadth will increase with human disturbance as there's more synanthropic prey species present on the landscape. So synanthropic prey species just means those raccoons and skunks and possums and things like that that are kind of at an enhanced abundance with human development. And then dietary breadth is just referring to the number of things that they're consuming. So in those natural areas, it'll be just deer and that breadth will increase. So I kind of have a figure to describe that breadth. So on the y-axis, I've got dietary breadth, the x-axis, the human disturbance, and kind of those have a positive relationship with each other. So as human disturbance is at its lowest, these lions are consuming pretty much solely deer. Kind of increasing with disturbance on the landscape a little bit. You're getting some hobby farms, maybe more of those possums and skunks and raccoons and things like that. You'll increase in dietary breadth a little bit. And then lastly, you know, once you're in these really urban areas for mountain lions, they'll still be selecting the deer, but there's going to be a lot of other things that they're eating, you know, whether it's domestic cats and goats and sheep and yes, they're just definitely more likely to get into those wildlife conflicts there. And so to get a handle on what they're eating, I do feeding site cluster investigations. So with the GPS collars, I mentioned that we get a location every 2 hours. And we can kind of track their movements across the landscape. And then all of a sudden, those movements are popping up from the same exact place. And that it means odds are that they're feeding in that location. So I've defined these potential feeding sites for my analyses as greater than 3 GPS locations within 100 meters. And one of those locations has to be nighttime or crepuscular, so kind of sunrise or sunset times. And then once I hike into them, I'm just taking note of the species that was consumed and just some general consumption status data. And so in 2022, I investigated over 200 of these kill sites, and just shy of 70% of them were deer. So I found 148 deer, and following after that is the livestock, so 37 livestock. And then you're getting into the more dietary or the more minor diet items. So the boars, the raccoons, domestic cats, and things like that. So that's the breakdown of what we found mountain lions eating all across the North Bay. And so this is a graph that I've made with the 2022 data, the orange line representing adult deer and the blue line representing fawns, and just the number of kills on the y-axis. So you can see that the number of fawns being killed and consumed really peaks around May and June. And so that's fawning period. That makes sense. The mountain lions are really taking advantage of that easy meal that's present across the landscape. And then that pretty quickly tapers off as those fawns continually grow. And then, you know, it's not such an easy meal once they're able to escape. But there is that really significant peak in the number of adults killed kind of in the fall there. And that's because of the rut. So when the deer are in their mating season, especially the males, they're being really careless. They're really worn down. And the mountain lions take advantage of that. And so you can see here a cluster where a big deer is consumed. You know, it's just really obvious looking at it, like, wow, something was going on there. That was a heck of a meal. So there's a ton of GPS points in a really small area. And then I go in there and I find large deer remains. And kind of on the opposite end of the spectrum, when they're consuming something smaller, like a fawn, you know, there's just a couple of those GPS locations present. So that's why I kind of have those parameters to help me define what's going on where, so that I'm not missing anything myself. And yeah, so once I hike into these locations, it's just a matter of noting, is it a deer? Is it a raccoon? Is it a possum? It's, you know, so what were they eating? Did they eat all of it, or did they leave it partially consumed? So that's an important factor just in noting the human presence on the landscape and how that impacts their foraging ecology. So are humans kind of pushing mountain lions off of their deer kills, requiring them to go kill again? Like, are they uncomfortable when they're feeding there? And then another thing that I take note of is just the overall condition of the prey item. So the way that I do that is taking a look at bone marrow in the femur. So your bone marrow is the last place that you lose fat before you were to die of malnutrition. So when bone marrow is in really good shape, a really healthy, fat, and happy individual is going to have really white and waxy bone marrow. And on the contrary, more of the unhealthy side, that bone marrow is going to become more red and gelatinous. So it'll kind of become like gelatin. And really, most of the deer, it's on the bad side, just with the drought. So the forage, you call it, the forage quality has been really, really poor. And so just kind of starting to wrap things up as a whole, what can the general public do and all of you guys do to really make a difference and ensure that mountain lions are persisting in this area for generations, kind of through the lens of preserving their habitats and preserving their prey? So first and foremost, I mean, for researchers, for the general public, for educators, you can't conserve for anything without understanding precisely, what areas do they use. So you can't conserve it if you don't know what to conserve and what are they preferring to eat. So in those urban areas, it wasn't entirely known, especially in the North Bay, what is the preferred prey. So we need to manage accordingly based on when those findings are kind of set in stone. So that's first, yeah, just taking part in things like this, and getting that knowledge base to know and build from to do additional things. So just overall kind of habitat things that are really important. The fencing around here is incredible. Every parcel is fenced, and it's really, really not a good thing at all for any wildlife species. I mean, I know that I talked about mountain lions potentially using this fencing to increase their hunting success, but deer are just absent on the landscape from a very large portion of the North Bay as a whole, with vineyard fencing and just different properties keeping deer out. So that's a really important thing, is just advocating for that, just an easy transition from parcel to parcel, eliminating that fragmentation on the landscape. And then another huge key is just avoiding development along drainages and corridors. So all those drainages, especially like the seasonal creeks and things that are dry for most of the year, those are highways for mountain lions and a lot of wildlife. So as soon as you start, kind of removing that underbrush and some of the debris that's in there, it's just less suitable. And eventually, if you get development along those drainages, it won't be used by wildlife anymore. And in areas like this, where there's already a lot of development, that's really critical. So there could be areas where there's just one drainage remaining, kind of connecting habitat patch A to habitat patch B. So as soon as that's gone, you can seriously lose mountain lions on the landscape. And then lastly, for mountain lions, just promoting contiguous large tracts of forest is really key. So, lions live in the woods. They want to be in the woods. They want to get away from people. So just kind of giving them that sense of refugia to do their thing, to move about, to have that home range in a relatively, ideal sized manner where they can find mates, they can raise young, and they can get the resources that they need to survive. Yeah, so just overall, I want to thank you guys for this opportunity today, and moving forward, I hope we can all continually better ourselves just to help and have mountain lions back. So yeah, just taking part in educational things like this to promote that coexistence and investing in wildlife for many generations to come. So I'm happy to answer any questions with the remaining time. I guess we kind of are out. So
yes, I believe it's the end of the colloquium class. So if we could give everybody could give him a big round of applause, please. Thank you so much, Jake. We really learned a lot to think about today. fascinating background info. The videos you showed were fantastic. Those maps, and then all the details about your work and about how we could help. So I will go ahead and put my email in the chat for anyone who has follow-up questions or comments. And I know the students have to go, but we will hang on and for at least another 10 minutes for anyone who wants to stay online.
Yeah. And, for those of you that are headed out, there's my contact details. Feel free to email me, send me a text, call me if you have any questions. I'll answer them. So.
All right. And then for any students or staff who or faculty who are still here, just a couple things about what the center is doing. This is one of 20 events this semester. So we have quite a few. We have 3 others that are virtual as well. The next one coming up is Tuesday, March 7th, Landscaping for Climate Change. So this one's led by the Environmental Horticulture Advisor for both Sonoma and Marin counties through University of California Cooperative Extension. And he'll talk about the various techniques that are available to address climate change on your small piece of land, and how climate change is impacting residents too, such as how urban trees can reduce heat and capture carbon, fire-resilient landscapes, rain gardens, planting species selections, and encouraging beneficial insects. And then if there's any professors in the audience, I highly encourage you to consider using our live from the field events as part of your classes. So these live from the field events were designed during the pandemic to give students virtual field experiences. And they have a ton of supplementary material, assignments, and suggestions for readings with an instructor guide. The one that's coming up next is in the works, so it's not on the calendar yet, but definitely contact me if you're interested. It'll be all about fish in freshwater systems. So I know there's some faculty I specifically will be reaching out to about that. And then lastly, I just want you to all remember there are multiple ways to engage with us. So please feel free and reach out for any reason. Other than that, I will take any questions from people. We did have some in the chat, so I'll go ahead and ask those out loud unless anybody else has anything first. So I guess I'll open it up now. Joseph, I'm assuming all the students are gone, but if they did have any questions, I would prioritize those.
Yeah, they're all gone.
Okay.
I just figured out the sound too, right as they were all leaving.
Oh my gosh. Well, we know for next time, right? That's great. Well, you did an amazing tech job. That was a lot going on there. So for people who are still with us online, I see there's 10 of us. So there's still some of us. You can show your faces now if you'd like to unmute, have your video show. We are no longer part of a class of students. It's just us all hanging out online. The first question I got, you actually answered. Somebody wanted to know if mountain lions could kill wild pigs. And then I saw in your chart that it was a 6% rate killed by pigs that you had found. Is that indicative?
Yeah,
is that just your research, or is that the broader research showing that same pattern?
So they do kill wild pigs. All of the wild pigs, I found 12 of them. All of them have been juveniles. So, it's probably not in a lion's best interest to try taking down an adult boar or something like that, just because, that'll put up a fight. And if you get injured or something like that, that's a huge problem. So definitely, but more of the smaller ones for sure.
There was another question. It was about sheep, actually, and let's just read it because it's a pretty fascinating idea. If a number of sheep are killed and not eaten, could it be the mother lion teaching the cubs how to kill?
Yeah, so it's kind of hard to single things out like that because kind of the observations and the data with the livestock issues is pretty messy. Definitely a potential. Another thing is even if it's, say an adult male, so no female or kittens involved at all, a lot of times the livestock still won't be consumed. So that's oftentimes just because a pasture with these goats or sheep in it will probably be relatively close to a residence. And they can just get pushed off. So if a landowner were to hear kind of an altercation with livestock outside, they go outside and yell, that lion's gone. So regardless, most of the livestock that gets killed isn't fully consumed. But definitely. So Males are most often responsible for livestock issues, but the times that females are involved is often when they have kittens that are kind of at that dispersal age. So they could kind of be like more of a, hey, mom, look what I can do. So definitely a factor.
Does anyone want to speak up with any questions for Jake? Hi, Alan. I see your video on. Did you have anything you wanted to ask him? Great mushrooms, by the way. Well, I'm super surprised. You may notice there's another person in here who has the same last name as me. That is my father. And he usually does have a question. He's calling in from Maryland right now. So I'm surprised. Maybe he doesn't know how to unmute himself. That could be what's going on too. Any other questions? I see Teresa's on the call. Sheila.
I guess I can ask a quick question.
Yeah.
Hang on, let me mute the other one.
Yeah, you're in an echo chamber. Oh, by the way, Jake, I used that kitten photo on Facebook.
The idea of trying to decrease fencing, and I think, this is a challenge, obviously, for anyone who has livestock, anyone who has their prize garden. What is a good compromise here? Because I think obviously getting rid of fencing for the rural or the farm community is not a realistic option for a lot of these things.
Absolutely. So I think, the main area, I'm looking at the backyard of where I stay right now. There's a fence, there's no livestock here. There's a lot of places there's no reason for the fence. So if you've got a vineyard or something of the sorts, absolutely you're going to need a deer fence, something to protect yourself or protect your agriculture from various things. But yeah, and even, a lot of properties that I'll visit, there's kind of fencing on fencing on fencing. So it's just very typical in this area to have the entire perimeter of your property fenced. I don't know if that's from more of a trespassing aspect, but that's kind of where things are problematic. So even if it's an agriculturally based property, if you've got a garden fenced, if you've got a pasture fenced, if you've got, a field with crops in it fenced, absolutely. But just having those almost more pointless fences, kind of removing what we can. It's not going to be perfect. It's absolutely, it's coexistence, right? So it's finding the balance, not making it lopsided in any one way. So just getting rid of any form of fence or boundary that doesn't really serve a purpose other than like property marking or something of the sorts.
Yeah, but like, is a 5-foot fence really much of a hurdle for deer or mountain lions? I mean, is it more of, I guess, obviously.
So it's definitely a bear. I mean, it's a barrier. So a lion can jump over your, 10-foot vineyard fence and something like that too. So it's not significant kind of as much for these macro larger mammals. They're able to get across, but still just in navigating them, it adds complications. So you'll even see a fence that deer can walk. There's always a deer trail right along that. And then if there's a fence gap, they're walking through that. So it's all about kind of maximizing that energetic efficiency. So they can get over things, but they probably won't unless they need to. And either way, it's just, if it's unnecessary fragmentation, I think it's good if we were to trend things in a way to remove what we can, just limit that in any way possible.
Good questions. It is 1:02. I want to respect Jake's time as well, but I do want to make sure we get to questions if there's anybody else. Awesome. Great. Well, Jake, that was really the most perfect public and science student presentation I've seen in a while. So great job walking the line there. Really appreciate it. All the work you put in. And I love that you highlighted the kill on Osborn Preserve, because you know what? I didn't know that it was a kill. I thought you just went up there and didn't find it.
Well, so I'd done that twice, but actually it was just recently, a couple weeks ago, I found one on there. So it's
Wow.
been P13 every time. So he killed a doe up there a couple weeks ago.
Oh, great.
So
Well, looking
he'll
forward
be
to seeing
back
what comes
through.
from that.
Yeah. Yeah. Well, thanks again. Definitely stay in touch, and I'm happy to answer any questions that may come up.
So exciting to hear about your journey, and best of luck finishing grad school. Thank you so much, Jake.
Yeah. Thanks a lot.
Thank you.
All right,
Okay.
take care,
Take
everybody.
care.